Today, I want just to think what would happen if ice, instead of floating on the surface of water, sank to the bottom. Imagine in the winter, when your pond in your garden or in the park froze, the ice, when it formed, would go to the bottom, and then as more and more ice built up, the layer of ice at the bottom would get thicker and thicker until in the end the pond would be nearly totally frozen and all the fish would be forced up onto the surface and would be squirming around on the surface till birds ate them or fishermen just picked them up. Or if you were at sea with a nuclear submarine, if the sea started freezing, it would be most embarrassing. Your submarine could appear on the surface of the ice and you'd be the mercy of whoever you wanted.
How is that different from the way it is now, except the fish gradually get squashed to the bottom as it gets thicker and thicker?
Now, the ice forms on the surface, and when it forms on the surface, it forms quite a good insulating layer, and eventually, if you're really unlucky, the ice could form all the way down and squash the fish at the bottom, but that doesn't usually happen because ice is a really very good insulator. And so most places, unless it's really cold, like in the Antarctic or somewhere like that, there will be liquid water at the bottom. Even in the Antarctic, there are underground lakes that have recently been discovered where there's liquid water right at the bottom. As you go deeper, the pressure goes up, and when you go down at low depths, the pressure is higher and the melting point of water actually goes down as the pressure increases. Now, the question is, why does it happen? Why does ice float on the surface of the water? And the answer is that the water molecules in ice are actually joined together by so-called hydrogen bonds. These are bonds of oxygen, hydrogen, oxygen. And they are in a very regular crystal structure. When you melt ice, these bonds break, not all of them, but quite a few of them. So you still have some of the water molecules joined together, but in a very random and haphazard way. So instead of having a very regular crystal structure with the bonds between oxygen, hydrogen, and oxygen, they collapse, and so the density gets higher. So ice is not very much lighter than water, but it's light enough to float. That's why just the tip of an iceberg sticks out. If ice was denser than water, icebergs would just fall to the bottom of the sea. You wouldn't have the film Titanic. It would have enormous effects on our planet if ice did not float. Because ice, as you know, is white, and so it reflects sunlight. So when the sea freezes and forms sea ice, this reflects back a lot of the radiation from the sun. And particularly in areas like the Arctic in summer, where it's daylight 24 hours a day, the reflection of the sun's radiation by sea ice is really quite significant. Sea ice floats particularly well because it is pure ice, but it is floating on salty water, which is denser than ordinary water, and therefore it is particularly buoyant. If you stop reflecting so much of the sunlight, that has implications for the whole of the Earth's climate, because more radiation is absorbed by the Earth, it will get warmer, and therefore more ice will melt, and so on. So if ice didn't float, our planet would probably be a considerably warmer place than it is now. Of course, the place where most people see floating ice are in their drinks. Now, it's quite important when you drink, at least particularly at the beginning, you drink from the top of your glass. So you want the first part of your drink to be really nice and cold. And as you chat away and tell stories and so on, the glass goes down, and so you're always drinking from the surface. So if you put ice cubes into a drink and they sink to the bottom, you'd end up with a warm drink. And that would be a social disaster. Alcohol, pure alcohol, is much less dense than water. And I just have a feeling that if you take ordinary ice and put it into pure alcohol, it would sink to the bottom. We'll have to try the experiment. We're in the vault, the bullion vault of the Bank of England, and I'm really excited. I've never seen so much gold. In fact, I've never seen so much of any element